Hey folks, this is Dat from Arize here. In today's video short, we're going to discuss embedding similarity search and why they're useful, not only in development workflows, but also in production workflows as well. And so maybe to kick us off, I'll talk a little bit about what are embeddings just as a review. And so the way I like to think about embeddings is they're kind of a bridge between the unstructured data that we have, for example, whether it's text data in large language model applications or maybe image data in computer vision models, even if you work with, like, for instance, ranking models, product or user embeddings. They're essentially representations of that data relative to some model, usually a deep learning model. And what they do is they actually embed or represent what is that data relative to that model. So if your model is looking maybe for specific features, that feature data will be encoded or embedded inside of that embedding. And why that's helpful or useful is that embeddings kind of share this property that, let's take the semantic or text space. In the LLM world, embeddings that are near each other in this very highly dimensional space, so for instance, A to 2 is 1536 dimensions, things that are, you can think, semantically similar or the same in kind of vernacular or maybe in theme, will be near each other in this embedding space. And things that are obviously very different, far away from each other, for computer vision models, for example, if you're doing an image classification, well, things that look similar, let's say you're guessing cat, mouse, dog, well, it turns out maybe all your pictures of cats will be kind of in the same area in the embedding space, maybe slightly different, but generally, if you have a good model that can do good classification, those will be kind of near each other. And so why this is important and why it's useful is that this similarity search really just helps us understand, like, hey, if I see an issue or if I see an example of something I'm very interested in, can I grab other examples that kind of look like that? And so, for example, with LLMs, it might be inputs or outputs. So we want to understand, hey, if a customer is asking for something, what are other customers maybe asking for something similar from the embeddings perspective? If we have outputs from an LLM, maybe we want to understand what are other similar outputs. And this can go in handy when we're troubleshooting, right? Imagine we're trying to find, hey, where are customers maybe being bad actors, for example, and they want to try to get around our prompt engineering. Maybe I want to find other examples of that and kind of block it. Maybe I have examples of bad outputs from my LLM system. And maybe I want to understand, hey, what are other examples of bad outputs that I'm getting from my system, so I can go and figure out why they're happening and kind of gather enough evidence to be like, oh, we need to go fix this. And so we can do workflows like that. We can also add additional complexity on top of that. So not only understanding, hey, where are things similar, but where are things similar under certain conditions? And we can add those conditions with other pieces of data, etc. And again, these things are useful outside of not only large language models, but they're useful in large language models, but computer vision, ranking, etc. Basically anywhere you have embeddings. And so what this helps us get to is, one, we can just recognize failures. When we see one, we can find kind of all of them. Not all of them, but we can find things that look like it. And it helps us understand, hey, if I see one issue, do I see other instances of it? Because you might want to say, hey, I might see this issue, but I don't really see it anywhere else. Or it's like, hey, I see this issue and I see lots of examples of it. So it really helps us understand where we should improve the system. Now, for a demo perspective, this makes a lot of sense if we just walk through it. But the first thing I want to cover is really the first use case. So this notebook will be available. But the way the data looks is really, I'll just scroll down here. And it's really just a summarization on some CNN articles. And so maybe we look at it in the platform so it's easier to understand. But maybe as an example, I'll choose this one. And so, we have some sort of article here. In this case, it's like Disneyland has captured the imagination for generations since its opening in 1955. But there's much people who, they don't know much about this place. And it seems like an article about Disneyland. So if we read the kind of summary, it's like, hey, Disneyland opened in 1955, has become a world-famous theme park. The park has undergone many changes since its opening. Disneyland has many interesting facts, including a tribute to Walt Disney's father in the window above the Emporium, etc. The park's popularity has continued to grow with over 16 million tourists visiting every year. Great. So if that's the summary, maybe I want to find things that also look like this. So Disneyland is a theme park. So what I might do is just say, hey, find things that look like this thing. And so when I first apply the filter, maybe I want to say, hey, these are the things that kind of look like it. Let's just kind of read. Speed camera in Birmingham has not been working for over 2 years. 3 women in Russia have been jailed. Former headmaster. This doesn't seem like it's like really working. So what I might want to do is say, hey, like this is pretty wide and I'm not getting this doesn't seem like it's pulling things that are similar. So I might tighten up that threshold. And so now what I have left is kind of 5 examples. And the first one is obviously the original one that we had, but let's read kind of these next 4 just to make sure. So this one is about, Venice is not just a place for romantics, but also for art lovers, with its Biennale art festival showcasing works of art from over 88 nations in May, George Clooney, blah, 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 blah. And so we can read through this, and tourists can pay $8 to take a lift up to, this bell tower. So I think for me, this is like saying, hey, like Venice is a city in Southern California or in kind of LA. It's kind of a district in LA. Similar to Disneyland. Disneyland is in Anaheim, also in Los Angeles. Also seems kind of like a touristy thing. It says tourists. So kind of similar. Let's maybe look at this one. The Tali Safari Lodge in South Africa has a regular visit from a mischievous African elephant named Troublesome, who enjoys emptying the resort's pools and spraying staff and guests with water from its trunk. Despite attempts to deter him, Troublesome keeps returning to enjoy the cool, clear water of the resort's kind of splash pools. The elephant's antics have become a source of amusement for guests. So also seems like a touristy place, while not in Southern California. Just also kind of goes with the theme of like a resort and tourism. Let's go to this one. This one is a carpenter from Southern California. Again, SoCal has built what could be the world's largest seesaw, measuring 45 feet in length and sending occupants 25 feet in the air. Also seems like a tourist attraction also in Southern California. And then maybe we look at the last one here. Natural World Safaris has launched a new series of ultimate safari adventures to mark its 10th anniversary, with the safari being divided into 4 areas: primates, bears, big cats, marine lives, etc. So also seems like a wildlife kind of park, a touristy area. And so for the most part, these are all kind of quite similar. And if we look at maybe the distribution of articles we are kind of seeing from this kind of data set, I think we have thousands of articles, some of them in different languages. Some of them just have nothing to do with tourism. So I think it did a pretty good job here, which is really nice. And when you think about, if I want to find other examples of something like that, maybe a similarity search is very helpful in helping me find things that look like that pattern. So I wanted to highlight an example of maybe the textual space. What I might want to do next is cover things outside of maybe large language models. I know large language models are hot, but in this case, we're looking at image classification. What we're really looking at is, I think, the fashion MNIST data set. So it might be easier to just show this data set in platform, and we can get a good sense of maybe what it is. But so here it looks like we have kind of an image, and we're doing a prediction. We have a prediction class and then a ground truth class, and that's kind of the data set. And we want to see, hey, how well is this model doing, and how does similarity or embedding similarity kind of help us out? So maybe I'm interested in a particular image type. So here this one is prediction class sandal, and the actual class is sandal. Maybe I'm just interested in sandals and say, hey, how am I doing with sandals? Maybe I want to find things that look like this. So I might apply a filter, and kind of off the bat, we kind of see, it's not perfect. We kind of see some high heels in here, so maybe I go in and tighten this up again. And so what I might want to see is like, okay, all these look like sandals? Maybe we have an issue here. Well, this one's actually messed up. The actual class says sandal, but interesting catch. But anyways, these look like sandals for the most part, but maybe I want to add another criteria. So not only things that kind of look like that sandal or sandals, but maybe I want to see, hey, where does the maybe actual class maybe not equal to sandal? And so what this might tell me is like, let's go back. So right now I'm filtered on, a similarity search to say, hey, grab me things that kind of look like sandals, but also tell me where the actual class is indeed not a sandal. So maybe I'm trying to find where our model kind of predicted sandal and where we actually didn't kind of meet. But if you actually think about it, this kind of looks like a sandal. It could also be a sneaker, but I think it is a sneaker with kind of this black patch right here, which kind of makes it look like a sandal. So a bit confusing for the model, makes sense. Also in this, it's also a sneaker as well. Could also represent a sandal, whether it's black patches or maybe open air parts of the shoe. I don't really know, but it looks like a sneaker to me. But what this might help me do is say, hey, what are things that kind of look like a sandal where it's not a sandal? And it might help me understand, hey, here's some edge use cases that we might want to, tune our model up in terms of finding specific features where we ignore areas on, dark colors on particularly sneakers so we can get better at it. But this is just an example of why similarity search is kind of valuable. It adds another tool to kind of our, understanding patterns in my system kind of toolbox. So I hope you found this helpful, but this should be available, and yeah, thanks for the time, and we appreciate it.